Our topic today is web application security for continuous delivery pipelines. And today we have Christian, who is the product manager for security at Avi Networks. Now, he has prepared 3 exciting live demos for you. And but before I get to the presentation, I just have a few housekeeping notes. First of all, this webinar is being recorded live now and will be sent over for on-demand viewing later. So you will receive an email to review the content again, or just simply share with your coworkers if you find the content to be useful. Second, you have a Q&A window here that you can type in your questions during the presentations and demos. We will get to it at the end with the live Q&As. Thirdly, we have uploaded some handouts for you, so you can feel free to download them. They have data sheets to talk about a platform, as well as specifically how WAF is going to help you with your security compliances. Now, without further ado, I'll actually hand off to Christian now to start the presentation. Christian, it's all yours.
Thank you, Lei. Okay, so good morning, everybody. My name is Christian, and I'd like to give you a little presentation today about application security and continuous delivery pipelines. So hopefully you can all see the screen, and just a very quick introduction. So this is me. I have been working with application security for the last 12 years in various roles. I would consider myself an AppSec defender if we're talking from a web application security point of view. And I'm always interested in all things security. And today I'd like to share one of my research topics with you, and this is really bringing application security into CI/CD pipelines. So today, what is the agenda? First of all, I want to go over my mission statement for this talk. Then I do a very quick introduction into the CI/CD. Then we go to the first demo by using the pipeline we've built to roll out a new version of the software. While that is going on, I'll start talking about the application security, how to build application security into the pipeline, mostly from a WAF perspective. Then we do a demo with that pipeline and enabled application firewall. And the last demo is, okay, now we have all this enabled, how do we tune actually a WAF policy via the API? So what do I want to start with? The mission statement, because that's kind of the whole idea. I want to show you a working demo of how we can include application security products into CI/CD environments. And this can be achieved if with the right tools. You really need the right tools for that to work. And the second piece that needs to work is that the teams working on this must work really closely together to allow this kind of automation to succeed. And I will tell you a little bit more about that later. So I said I do a little introduction to CI/CD. I brought 2 quotes with me from Martin Fowler and Jess Humble here about what CI/CD really is, or continuous delivery really is. And when you read these quotes, one thing that springs to my mind is they are not mentioning security at all. And now we could argue, why is this? Or is maybe security is implicitly included in the test step here? I would argue that out of the discussions I had with developers who do CI/CD pipelines, the amount of security that is built into this automatically is very, very low. So I would argue it probably needs an additional security step here instead of including it in the overall testing or testing stages. So without further ado, let's look at how to run a successful CI/CD. Again, this is a very short version just to get on the same page in terms of what we're going to expect from a successful pipeline. First of all, let's talk about the goals. So the goal of running a CI/CD pipeline is that it's predictable, it's reliable, it's fast, and in the end provides better quality of the software you're shipping. And this is loved by everybody. Business, sales, PM, and customers love it because features, enhancements, and bug fixes can be delivered really quickly. So very, very handy. Then operations love it because you get better quality. Every release is tested and every change is tested automatically as well. That results in lower downtime and lower risk for releases. Then organizational, it's efficient. You don't need endless meetings because you have this automatic pipeline that runs all this. It empowers the developers and the teams to develop the software without having to wait forever for the next yearly release window. And it's usually well aligned within the organization itself. So as a very short introduction to the goals, then let's talk about the deployment step. And here I want to, so this is the more of the whole pipeline. I want to focus on one aspect of it, and that's really how you do the deployment automation. Because what we want in the end from a CI/CD pipeline is that we have zero downtime deployments. Either you do a blue-green release where you test the new release and then switch to it, or you do a canary release where you have only a certain part of the traffic going through the new release and then switching over to that incrementally. This is really, really important that you have this zero downtime, and our demo today will include a blue-green release, and later we will look at this in more detail. Then we start with the process. So how does the overall process should probably look like? You have a development step, you have a build step, a test step, a deploy step, monitor and validate step, and then the new software is taken in service and the old software is taken out of service, depending on the results of those of each individual step. And to allow us to make a decision about these steps, we need success metrics. And here, the basic principle is we need to express the pass or fail decision for each of those steps. For that, we need to use normalized metrics, so every run of our pipeline produces the same metrics we can actually look at and compare over time. And we should focus on metrics that measure quality instead of quantity. So one metric that tells you much about the application is much better than 100 metrics, for example. And in the end, they provide an overall benchmark to your application over time. So if you have all these success metrics over time, you will get graphs that maybe the application has a faster response time over time, or less errors. All of that is really good to measure the quality of your CI/CD pipeline. So when now we have built the foundation of what we need to run that, let's go into the first piece of the presentation demo here. And first I want to give you a quick overview of the environment that we've built. As a demo environment, we have chosen to build this around the Vulnerable Application Hackathon. So this is the application code we are deploying, and we have built a complete application lifecycle around this, including security scanning and the IWAF protection that I will tell you more about. All of these parts, the application lifecycle is built as infrastructure as code. So instead of working with the pipeline itself, you tell it in a configuration file what to do as a coding as code, and then it deploys that automatically. How is that? What's the foundation of the demo? It's a Kubernetes cluster, so a cluster of 3 Kubernetes nodes that we can control via a dashboard. And I'll show you that in a second. Within that Kubernetes cluster, we've included the Avi Vantage load balancer with the IWAF module that helps us with the security, bring the security into this pipeline later. As a CI/CD tool, I use Concourse to run our pipeline. We have a local Git repository in the form of Git that allows us to store all this infrastructure as code files, and also the application, of course. We have a Docker registry because the Concourse pipeline will create Docker containers that then get deployed to this registry and executed. We have an OWASP scanner, which is a security scanner that allows us to scan a new release of the application for security vulnerabilities, also in a Docker container, and gets created on the fly as well. And all of these services run locally. So one of the ideas I had for this demo were none of it should be dependent on any external cloud functionality. So all of this is local. You can completely build this in your environments without having to access a third party in the cloud. Okay, so to understand a little bit better how the AVI Vantage solution is integrated, we have to look at the architecture of it. So AVI itself contains of a control or separates control and data plane. The control plane is our controller, which does all the integration into Kubernetes, for example. And we have the service engines, which are the pieces that do the actual work, the actual load balancing as the data plane. The service engines have the application firewall included as well. And as you can see, the service engines can run from a bare metal install to a container environment, which we use in our demo today. And how does that work within the Kubernetes environment? The AVI controller directly talks to the Kubernetes master, and from there it gets all the information to deploy service engines on each of the Kubernetes nodes. These Kubernetes nodes then have an ingress and east-west traffic load balancer and additional proxy functions on top of that for all the traffic that they handle. Okay, and now we'll jump right into the demo, and for that I'll just give you an overview of my the actual running systems here. So I start with the Kubernetes dashboard. Let me simply refresh that so I'm still logged in. So here you can see that we have the Kubernetes dashboard running. It will, once it's loaded, show us that we have all these deployments of the application. So we have multiple versions running, and I will tell you more about it and create a new one in a second. We have the OWASP ZAP, we have the registry, the Concourse. All of that is running within this Kubernetes environment. And all of this is running through the service engines that I just mentioned. Also, we have these ingress controllers, so incoming traffic is run through AVI service engines as well. And here, the Hackathon application will, once we create a new version, will have a new ingress controller as well. Next up is the AVI, our AVI controller, which provides us an overview of all the virtual services configured. As I said before, all of this will be infrastructure as code, so I will not touch any of the UIs today, but rather edit some code to deploy a new version. And here we can see the Hackathon application is actually up and running. It is my third browser window here shows us this on hackathon.avi.works. We have a Hackathon application, which is a vulnerable application for our purposes of showing you a little bit of application security today. Next up, we have the Git, which is our Git repository. Within the Git repository, we have Hackathon itself as the application code, and we have a Hackathon infra repository, which automatically will get all the infrastructure changes we do committed, so we have a full audit trail of everything that's happening. And lastly, let's look at the Concourse. I have a couple of pipelines configured. This is my Hackathon pipeline, which we'll look at in a second, and I have a WAF policy pipeline as well, and I'll tell you more about that at the end of this demo. Going into this, we have an init step, deployment step on Kubernetes, where all the new containers are deployed. We have a run a security scan, blue-green release step and a release to infrastructure as code, where we will save all the new configuration. All right, and how do we start this? So let me change again to the terminal. Okay, you hopefully should see my terminal now. So what do we need to do? Let's change so I get here a CI Kubernetes Hackathon YAML file, which is our infrastructure as code file, which defines all the needed pieces for the Kubernetes to run our Hackathon app. And as an example, I will just change this and remove my annotation here. The annotation we will enable later again. It's the simple two-line annotation that allows us to enable the application firewall. Then I'm doing just the version, incrementing the version here. So we have a new version to deploy. Let's take 9.2 today. Then I will commit this webinar version 2. And again, save this. Next up, we're going to tag the release. Tagging the release in this case makes sense because all of the other pieces that we will later see we have committed, like a WAF policy, will get this Git tag as well. So we can always go back and deploy any of the previous versions in exactly the same fashion as we had them when they were first introduced, because we have full control, full version control of all the data that is needed for that. And then we push this to our Git repository. And now Git tells us everything's okay. And we're basically done with this step. Let me show you the pipeline. Kind of going back here, because now in a couple of seconds, the Hackathon pipeline should be triggered by this new version. And it will run through the step of first getting the initiation done and then getting all the variables. So it has started. Give you an idea here what's happening. In a second, it will show us, yeah, here's the reference to the new version 9.2. And we're running now through this pipeline of what I just mentioned. Getting initialized, doing a deployment on Kubernetes, creating all these new containers, running a security scan, and so on. I will now let this demo run its course a little bit because it will take its time to do all this. Just remember that this is completely a new version that is deployed next to the old version, so it doesn't interfere with the old version that is running in production. And therefore it creates new Docker containers and all of that, and that takes just a couple minutes longer than we want to look at this nice little pipeline screen. Okay, while this is running, let's talk a little bit more about application security. And I want to start with looking at a more general context. So CI/CD in an application security context. What parts of, so application security is actually much more than application firewall, of course. And so let's have a broader look of what we could include here. So first of all, we could include things like DAST or SAST scanners, basically dynamic security tools that scan from the outside as a black box, or static application security testing tools that look at the application code and try to find vulnerabilities there. And those are usually automatable and tester staging through the APIs that they deliver. What would be a success metrics for that? So if you run a scanning tool, security scanning tool, the vulnerabilities should be in the within the expected numbers. If you have known vulnerabilities, there shouldn't be any new ones. If your vulnerability count is 0, even better, then any new one would be a failure on the on this success metric. You could also include RASP tools, so runtime application self-protection tools that are usually built within the application toolchain. So essentially, they become a part of the application. A very easy success metric for that would be the application test is actually green. We could look at other security tools like DDoS protection, transport security. So all of this should be done automatically as well. If your application uses uploads or provides downloads to the users, we could have a virus or malware scanning automatically built into those as well. For each of those, you have different success metrics, so it really depends on the requirements of each of these tools. But all of these, with the right APIs, could be automated in a pipeline. And lastly, I want to talk a little bit more about WAF, which we will focus on for this demo. So WAF provides this application protection. It's usually proxy-based. And today I'm making a good case for that the WAF policy needs to be part of your application infrastructure code. So essentially, when we look later at how we deploy the WAF and change the policy, it gets committed right next to the application code and to the infrastructure code. So whenever you have to redeploy a certain version, the WAF policy is exactly as it was when you tuned it for that specific version. A WAF in that case should be deployed in all the environments, so in dev, test, and production, just to make sure that the earliest possible situation where you may run into false positive or any issues with a WAF not working well with your application traffic, you find it early and can fix it early. A very easy success metric here is the application test is green while you deploy a new version of the application. For a success metric while doing or running the application with a web application firewall, you can have many other success metrics, like the error count from the WAF is at a usual low, and any change in that behavior would then trigger an alert and needed to be investigated. So now that we looked at the tools itself that we could integrate into a CI/CD pipeline, let's look a little bit about the challenges that we see when we talk about application security and the development environments. So all of these in my various discussions with teams that run pipelines or try to get in to run their software and development pipelines have come up, and I want to quickly go over those. So first of all, I hear a lot, the infrastructure that does not support the security requirements. So the product, the vendor does not support the security requirement X or foo. And the reason is usually it's not built for a modern application architecture where you need a lot of APIs to automate all this deployment piece and so on. Then I hear a lot, security needs to be a first-class feature, but it may not be. That always comes down to that it needs to be part of the company DNA. If the company has a process where the security is a first-class feature, then you don't have a challenge, right? But it's usually it is not. Then today I'm making a case about security education as well. What I hear is that there's not enough security education done, and any developer that writes code needs to have a basic understanding of what the implications are if the security best practices are not met. And we see that happening a lot in today's world, that we have new breaches on a daily basis, and that results in the fourth step here, that features usually are competing with security. So when you actually design and plan a correct security process into your development process and your secure development life cycle, then they shouldn't compete for the same resource, but use the same resources. So security is a top level feature. And lastly, let's look at team silos. If a security team is very siloed and it will not share the responsibility of making the overall product safe, then it's likely to fail. And so teams need to share the responsibility, because we have a shortage of security folks in the companies, and we need to really share the responsibility there. Okay, so before we move to the next slide, let's actually have a look at our demo. So to the next topic, I mean. So where's my, I need to switch back to the Firefox here. And we can see that the security scan is still running. So I can show you a little bit about what it does. Very good, perfect timing. So the security scan, as I mentioned before, we're using here an OWASP that is fired up when a new version is deployed. And now it accesses the new version on a new DNS entry here, has accessed this, and now starts spidering the target. Once the spidering process is done, it will go into the scanning step and actually look for security vulnerabilities within the application, in the new deployed application. Some thoughts on this here. We had to cut the amount of scanning short for the demo. So we're actually looking just for cross-site scriptings in the demo, because otherwise a scan takes a lot longer than we have time for in a webinar to actually show you this. But the idea is really that every new application in our pipeline gets a security scan. So when there's a new code released, we don't publish it to the world with known security issues. And so let me go back to the deployment step just to give you a little bit of an idea here as well. So here, for example, the Kubernetes YAML file that I changed earlier, I added I commented out this annotation that was committed here and used for this 9.2 release. And if we go back to our security scan, it should be finished in a second. Yes, very well. And we actually see, okay, we have the security scanner found cross-site scripting here. It will mark the security scan as failed, and will in the next step then remove all the new version from the platform. So it completely cleans up the 9.2 version, because it's not something that is going to be live. So when we talk about success metric, the success metric here was there's no new security vulnerability, but we found one, and this is actually in the search string of the Hackathon application. As I mentioned before, this is a vulnerable application, so we are, of course, bound to find something here. And there, we will look at this vulnerability in a second. So as a very simple alert that was allowed to go through here. In the pipeline, this is now marked as red. And as I said, it has completely stopped deploying this application. In the Kubernetes dashboard, it has logged me out. Let's log in again. In the Kubernetes dashboard, it has been already removed as a deployment, because it was not, where am I here? In the last step here, I'll show you. Come on. As part of this, it will go into the Kubernetes deployment and run a kubectl delete on this configuration. Okay, so we have the first pipeline that failed. Now let's do a second run, second part of the demo by enabling WAF as a security step here. And I do this again in my terminal. Let me clear this, and we're going to edit the Hackathon YAML again and remove the comment out here. So as you can see, this infrastructure is called. All we need to do to enable the application firewall with an application firewall policy is to enable this annotation. Okay, and save this, then change the version file to be consistent here, then commit add WAF version. Okay, we have a new committed version. As mentioned before, very importantly, we need to tag the new version and then push it to the repository. And that is all we need to do in terms of running a new version. Let me just confirm in the pipeline here that it will restart the pipeline. So the init step happens, and now we go back to our slides to talk a little bit more about WAFs in a CI/CD context and wait for the pipeline to do what it's supposed to do by deploying our 9.3 version. All right, here is a slide again, and I want to take a minute to talk about WAF challenges with CI/CD. And application firewalls are not a new tool on the planet, right? So they have been there for quite some time. But when we look at the challenges that these application firewalls have that have been created 10, 15 years ago with current CI/CD, then you look at that they usually use some proprietary hardware. So using hardware is something that with a CI/CD pipeline is really not something you want to, because as you can see in our demo, all of this is scalable. You can program it and run it anywhere I want to do this. So in our case, Kubernetes. So hardware is not a good thing to have. So we can't use a hardware WAF. Then we need a WAF that can be managed centrally. Legacy WAF usually were managed per device. So that's not going to help us either. And I will show you once the demo is done that we manage many of the all of these WAF installs on the RV controller centrally from that as well. Very importantly, you need WAFs that can support automation. And this is a big piece where legacy WAFs were not written for it. They were written to be included in your traffic coming in your ingress traffic, and take all the ingress traffic, scan it, and then provide those requests that were deemed good to the application. But here, as you can see, we need full automation. We need the REST API to completely program it with a new version and roll it out automatically. Then next thing, telemetry. It's very important to have as much analytics as possible coming out of WAF. And RV here has a built-in analytics engine that gives you a lot more information that I can actually show you today. So and I will give you a couple of examples, but we have a lot more information that you can use to make good decisions about is this success metric green or red. And of course, static capacity is a high problem of a legacy WAF. What happens is if you can't scale with your application traffic, it gets really hard to deploy a WAF in front of any application. In our case here, we could just fire up more service engines, more containers, or more nodes in Kubernetes and handle more traffic. And all of this would be done automatically by the AVI controller. So when we look at what we need to have as a WAF, as a properties for a working solution, and I've categorized these in 3 buckets here. You need the right mindset, you need the right infrastructure, and you need the right process. And I want to start with talking a little bit about the mindset. Application firewalls have the power to block any application traffic that is deemed an attack. And therefore, to make it work, the application developer, the security team, and the networking team, if they are not in one DevOps team anyway, they need to work well together closely to allow an application firewall to be integrated. Then the application developer in the first place needs to accept the WAF as an additional security layer to protect the application. And as they need to accept it as a help to actually make sure that if there's a vulnerability found, they can fix it quickly and then fix the code very shortly after. Because even if you have a CI/CD pipeline, finding the right line of code in your thousands of lines that you have for the application may take longer than deploying, for example, the application firewall, having it deployed automatically. Then the application developer, through the analytics provided by the WAF, can actually look at the application behavior from a very different perspective, because the application firewall will either alert or block behavior that could point to an attack vector on the application. So all these additional analytics that are provided can help the developer to make good decisions of maybe looking at certain pieces of code and examining if that piece of code is secure. The next item would be that the security team, of course, as in the mindset step, defines the requirements and does the risk assessments on the application. So if the security team defines the requirement that every rolled out application is supposed to have WAF, and then does risk assessments on these applications and provides different policies for these risk categories, that's the first step of getting it done in a pipeline way. And what I also want to stress, that a security team needs to provide oversight and guidance, because I talked earlier about the shortage of application security knowledge and the need for education and knowing where application attacks happen today and how you can actually fix those and be more secure with your application development. That's a guidance the application or that the security team can take. When we look at infrastructure, I mentioned a couple of those before, so I'll go over them a little bit more quickly here. To run all this in the dynamic fashion that we showed today, you need a pure software solution that can be deployed anywhere. You need integration as deep as possible into your host system like Kubernetes, either a load balancer or a web server for the WAF. Then you need all these automation pieces. I'll already shown you some of it. So maybe APIs. So for example, AVI has a full REST API. We have a Python SDK, Go SDK, and other integrations, or Ansible tools, for example, Terraform. All of that needs to be available to support the organization. Orchestration integration needs to be. So if you have a scalable application, the infrastructure needs to scale as well. So in our case, the controller will create more service engines when there's the need, there's demand for more traffic to be handled. Then, of course, I talked a lot about insights and metrics, about how to make good decisions in these cases. And then we go into the process piece. The WAF, as I mentioned before, needs to be part of all the stages of the development process. If you build it into the pipeline, it's already there. So you don't have to do an extra step to do this. I strongly advocate that the WAF policy that actually guards the application should be owned by the developer and kept with the application source code. This is important. The application developer knows the application best and can actually make the best decisions of how to tune the policy. And the security team can audit that process if needed. In our case, in our demo here, for example, since all the new policies are committed to Git, we have a full audit trail of what's happening. Yeah, and in my mind, we need to deploy every application with a default security policy, and that is defined by the application type and the risk profile for that application. So how do we bring this into this workflow? I showed you this when we talked about CI/CD. So how do we get this the WAF into the CI/CD workflow? In the development step, the WAF can be part of the development process. So if the developer runs local versions of their environment and has those things automated as well, the WAF is part of that too. The WAF policy is updated by the developer, is tuned by the developer, and you can either say, yeah, we got oversight by the security team, or maybe the changes need to be approved by a pull request on Git, for example. And since the WAF policy is part of the application code, it then gets executed and rolled out with any of the next steps. So if we look at the build step, building an application, the WAF usually doesn't have a part in this. It doesn't directly influence the application code, so there's no need to look at WAF from that perspective. But the next one is the test step, where all tests are run on this new build. So for example, we did a security test run with the OWASP ZAP. Since the policy is stored, we have the policy in place, so it will be used in any of the testing. So if any functionality fails, then you can go back and iterate on this as well. A caveat for testing, of course, the simulated test traffic is usually inferior to the real-world traffic. So you will see much more scans and bad traffic coming from the internet than from your test scripts usually. In the deployment step, the WAF itself gets deployed alongside the application code since it's part of the whole pipeline. The next step is monitor and validate. So you can now look at the metrics provided by the WAF that provide necessary insights into the expected WAF behavior and how to measure the health. So if you have a new version deployed and it has a lot more blocks or alerts from the WAF, you probably don't want to give that in service. So you have these metrics that you can actually base decisions on. And if you do it wisely, you can automate these decisions very quickly as well. And the last step is bringing it in and out of service. So since we have deployed WAF alongside the application, and now the next step is if all the metrics are good to go or is green, then we can change to the new version in, for example, a blue-green release or a canary deployment, depending on what is built in the pipeline. And yeah, so let's go back to our demo. And look at the Firefox. So here you can see that the new run of this 9.3 version. Let's look at the outcome of the scan. It had no high severity vulnerabilities found. And the reason for that is we added this annotation to the Hackathon YAML file that automatically deployed a WAF policy that is using signatures to find these attacks, was automatically deployed, and now the scan is green because the attack is not exploitable anymore. So when the security scan was done and finished, it went to the release step here, blue-green release style, and lastly, it's committed this code into our repository. Just a quick overview in what has happened in the Kubernetes dashboard, and logged out again. It will now give us a 9.3 pod and ingress controllers and all of that created for us fully automatically for this new version. So we have the deployment and the pod and so on. We have in the AVI controller, oops, what was that? If we look at our available virtual services, the Hackathon virtual service, if we click on this, we'll now see that we have a new pool that was created that is actually running the 9.3 version, and we still have a backup pool. So one of the important pieces here is if in the operations this new version would degrade for whatever reason, not WAF related, any other reason that the application code is wrong, we could simply switch back to our 9.1 version, which was green before that. And again, all of this was done for us fully automatically. And the little shield around our health score here provides us with the information that the application firewall was deployed on this virtual service. I wanted to quickly give you an overview of what has committed. So 3 minutes ago, a couple minutes ago, we added a new Hackathon YAML. I'll quickly show you that. Here's a new version, 9.3, and in the bottom here, we have the annotation was added as well. So infrastructure as code 9.3 version fully in our repository. We can always run the pipeline again to recreate it. So this was the idea to show you that integrating the application firewall into this pipeline can be done with the right tools. And I have one more extra demo for you that I want to share, and that is the next step. For now, I have all this the security built in. How do I tune the policy? Because when you're working with WAF, you know that you need to tune the policy in cases where you have, for example, false positives. For that, let me give you a quick idea of how this can be done. First of all, let's go to our Hackathon application and just try to exploit this seen or found vulnerability by the scanner. This will now get answered by a 4.3 response code, which essentially is our application firewall saying, no, this is an attack, I'm not letting this through. An interesting piece that the application firewall will provide us is the request ID. I will just copy this request ID because in any of the testing environments, this request ID could or gives you the entry point to very quickly tune the policy if you wanted to. So there are multiple ways of doing that. You could go to the AVI controller UI and change the policies there, but in some cases that might not be an option, right? If you're running this on a large scale, deploying application firewalls with every application you bring on board, you don't want to give access to the AVI controller, for example, to a developer. That's totally understandable. So how can we fix this? I've seen people doing their self-service portals where developer registers a new app, and then the self-service portal will basically create this pipeline for the developer. And one of the next pieces of a self-service portal could be, okay, I have a piece of the portal that allows me to tune the policy. And why can we do this? Can you see my terminal, by the way?
Yes.
I don't think so. Okay, now you should see the terminal. How can we tune the policy without giving full access to the developer, to the AVI console, or even how can we provide tuning mechanisms into self-service portals? And since AVI has a full REST API, we can leverage that to tune the policy anywhere we like. So even via REST call. So what I've done here, I've just did a little demo script for this. So running a Python script that connects to the API of the AVI controller. It asks for a request ID. So think about the developer has an issue with the app. It has a false positive. He has the request ID. He doesn't need to go to any other tool. He can use the self-service portal to enter the request ID, and it will provide a log query entry here for us. This is just part of the actual log entry. So this is the interesting lines that I found we could use to make a decision. But there's a lot more actually in the API that we could gather. For us, we can see that my client IP here triggered cross-site scripting on the search string parameter. The text string was this prompt for a password. And we see that the rule ID of the CRS here, 94100, did block it. So to tune the policy, AVI has this idea of creating exclusions. So let me just from the API here create an exclusion with a couple simple steps. Yes, I want to create an exclusion. And how do I do this? I could now create a rule exclusion, which means that I just allow this rule to allow this request in the future, or create a group exclusion on all of the cross-site scripting. Since this is a very simple cross-site scripting, it makes sense to do a group exclusion. So what now will happen is it will communicate with the controller, change the policy, trigger an update of the policy into our pipeline, and then actually commit this new policy with the right version number to our Git repository. And this gives us the full trail of audit again to see what's going on. And here's the pipeline that triggers the triggers the new policy. So this will now export the WAF policy and push it into our infrastructure repository. Again, a way of automating all of this. And if you build this into a self-service portal, all of this is completely invisible to the developer who just needs to use it. And it will appear in a minute here in our Hackathon infrastructure repository. And lastly, to finish this off, I wanted to give you an overview. So now I'm allowing this attack to happen. And on our Hackathon, if I now execute this, this attack, it should now go through because we actually tuned the policy via the API without any other means than running a little script that communicates here. Okay. So while this is exporting, we have 5 minutes left. I would stop the demo now, and we go into maybe 5-minute questions if we have any. Yep, thank you very much, and let's see what we have.
Okay, so while Christian is getting back to the last slide, I have a question from Bart, which I answered offline, but I'd like the group to know. He's asking whether the presentation will be ready and whether the recording will be ready. So as I mentioned in the beginning of the call, you will receive a on-demand recording of the webinar, and we are also uploading the slides to SlideShare. So if you go to slideshare.net/Avi network, later we will upload the presentation slides there as well. So we believe in open really just sharing the information and educating the team on security practices. You'll also find content of other webinars we've run, so if you find them interesting, feel free to take a look and then watch it on demand as well. Okay, so now that's the actual question. Let's keep the answers really quick. So Manish was asking, is what you're showing a shipping product, or are you just showing the product? That's a great question.
Yeah, all of this would be
Second question is from Will. Says, do you support automation tools like Ansible and Terraform? Yes, can you show the last slide, the next step? Actually, we provided a link to an Ansible, how to get your hands dirty. I know the whole demo setup is more involved than just one script, but we'll give you kind of a feeling of it. Second question is from Jonathan. Says your demo is done in kind of a closed environment, but do you support that? Another question from Alexi is, in this frequent deployment environment, with false positive resolution be a bottleneck? Is there any way to speed up the resolution of false positive?
So I think that the application here when even the
Gilbert has a question. You show Kubernetes, but do you have feature parity for OpenShift?
Right.
Last question from Matt. He's asking, can you show the WAF policy in the Hobby controller UI?
Sure.
Yeah. So just to everything, because Avi is 100% RESTful API enabled system. So whatever you see in the UI could be done in the scripting or using automation tools. But I know some people like to be able to at least view the policies or through a point and click manner instead of scripting. Not everyone.
Yeah. So as a and and
All right, thank you. Thanks everyone for being on the line, and we concluded our webinar. You will receive an email shortly after. Thank you so much.